Okay, well, it is a minute past, so I think we will go ahead and get started. Now, when I pull the participant screen up, do you see that participant screen or do you just see my slideshow?
It's just your slideshow right now.
Okay, that's perfect. I wanted to make sure, I want to keep watching in case somebody is working on joining us, so we make sure and add them in. But we'll get started with this. We are recording this session and we will post it online so that more people can view it at their convenience. I think this will be a really good, it'll be a really good use of our resources with all of this online work so that we can get this information out there and start directing people to it a little bit easier than having individual conversations, because this is information that we need to have shared broad and wide, and not just within the boundaries of Nebraska, not in the boundaries of the Sandhills or Nebraska. This is really a much larger topic that we're talking about here, and one that is impacting the beef industry drastically. So I'm thankful for those that are on. Hopefully more will join us as we get started here today. And a big thank you to Dirac for coming and talking and making himself available for this information. We had planned a face-to-face meeting, but that did not work out due to the COVID information, so the COVID pandemic. So we decided that we would get together online and try to share this information too. I thought I would share a little bit of some tools that are available before we start talking about why we need to get into this, why we need to start controlling cedar trees. Dirac's really going to drive home the fact that we need to do a better job of controlling our cedar trees. And I want people to know from the very beginning that there's so many tools available to you, whether you want cost share funding or not. And that's why I put technical assistance at the very top. There's people in the Sandhills Task Force, as well as other organizations that are extremely willing to help you out, whether that's just talking about how you're going to attack your cedar trees, what method you should use to do it, who you want to hire, all of the things, and maybe even what you should plant for a windbreak instead of cedar trees. Mechanical clearing is another option, and you can do that on your own, or you can have cost share assistance through the Sandhills Task Force or a number of other partners out there. There's a lot of people willing to help share the cost of clearing these cedars, because we know that it benefits the environment as a whole, not just wildlife, not just ranching, but there's so many different levels that getting rid of these cedar trees helps. So there's mechanical clearing and prescribed burning, and we've got good resources out there to help you. And then we've got the Volunteer Fire Department Prescribed Fire Award too. And that's really useful for you for getting people to help use the equipment that's already on the ground to help with private lands prescribed burns too. We've had really good success with departments in the Sandhills helping out with that. And then the bottom one, I put the cedar literacy page, because that is something that Dirac and his team created to share information about cedar trees. And it's great information, it's updated, and the more we know, the better we can start fighting these cedar trees. And quickly, the economics of cedar invasion, just using some simple math. I put these two slides together just so that we know from the rancher perspective that these things are really impacting our bottom line. Cattle don't eat cedar trees, and grass doesn't grow underneath cedar trees. And water is typically the most limiting nutrient in the Sandhills. Not the last couple of years, but we've had some pretty unbelievably wet years. But as we look at history in a normal situation, we typically have water as our most limiting source, and these cedar trees suck up quite a bit of water. So with that information, I just added some numbers, and these are numbers that are, you know, what I pay for for grazing, you know, $365 a pair for 5 months of grazing. And if you're the landowner, if you're putting 60 pairs on your 640 acres, that's $21,900 worth of income. If you have a 10% canopy cover from cedars, which is not all that much, and we see it quite often in the Sandhills, if you're going to stock it properly, you're going to need to decrease your carrying capacity by 10%, which is 6 pairs. And so your lost income per year is $2,190, which is $3.42 per acre per year, and that increases exponentially year after year because these cedar trees keep making more cedar trees out there. So I wanted to put that little bit of information out there. That's just going to feed into what Dirac is going to share with us. We've got contact information for Ashley and myself. Ashley Garles is on the call or on the webinar today. I've got her contact information there as well because she deals with all of the projects for the Sandhills Task Force. I can sure talk with you about some of the information presented, and I can talk to you about the organization and talk with you about projects too, but she'll be the one you're working with. So I'll show this slide again at the end, but at this time, I think we'll switch over to Dirac and let him get started with his presentation.
Well, thanks a lot, Shelley. Shelley and I had a brilliant idea after about 4 straight days of rain that wouldn't it be nice to have, you know, dinner and a movie. And then of course we hold this probably on one of the nicest days that we've had in a while. So, but I really think it's a great opportunity because we just see so many groups starting to talk about moving forward to better address the issue of woody encroachment. And I really think, thanks again, Shelley, for setting that up so nicely. What we're seeing is maybe for the first time that I've heard in my career, we're seeing scientists really starting to talk about this as a broader national issue and starting to communicate that in Oregon, it's just a different juniper species than here in Nebraska, than what's in Texas. And then it's just a different woody plant, but we're starting to see similarities all across all of our Western rangelands. We're seeing the Cattlemen's Association, Cattlemen's group starting to talk about this as, wait a minute, this is a national discussion and a national issue. Agencies are coming together and revamping plans, addressing the true scale of the threat. And some of those conversations are even here in Nebraska and surrounding states on really, you know, the NRCS taking leadership on trying to create a multi-state initiative that starts to address this. And so I've been fortunate to be in multiple rooms across producer rooms, the industry, the scientific rooms, and the agency rooms. And I'm just seeing a scaling up. We're recognizing this isn't just a local threat in one place anymore. It's an issue that's really plaguing us across multiple areas and multiple geographies. And I get the benefit of traveling around and being able to see that. So I think one of the best things we can do is learn from what we're seeing across these geographies so we don't have the same mistakes playing out over and over again across generations. It's really, maybe that's one of my most important jobs. So I'm going to step back and tell us this story because when we talk about this, people keep pointing to the Sandhills as one of the golden opportunities that exist in the country and other areas in Nebraska as well. But so I really appreciate this. Always looking forward to getting out, especially now more than ever, and meeting with people. And I want to put some of what we're talking about into practice. But thanks a lot for everybody who's been doing a ton of work that is listening at home or watching this later with the recording, because there's really more of an army or coalition of people starting to take leadership on the issue. In addition, this is what you're going to see is a lot of work from my lab, and I want to give a special shout out to Dan Uden, who's a new assistant professor at Nebraska, as well as Dylan Fogarty. He's online here, and he's been doing a ton of coordination with private lands groups and and really spearheading that. So you'll see his name out a lot more, I'm sure. So with that, let me move into what we're looking at here. So I want to start with really setting the stage of what we're thinking about and what we're looking at here. So we're talking about this, when we're thinking of places like the Nebraska Sandhills, this is what grasslands look like when we think of grasslands or treeless systems at large scales. So there's these new platforms where we can actually track how vegetation is changing over time. We finally have products that are more like the weather. And there's more and more of those coming out over time. This is an example from the Rangeland Analysis platform, where this is where woody covers less than 5%. So you can see all the green of the Sandhills. You can see the Flint Hills pop, the Gypsum Hills or Red Hills of Kansas. What I want to paint here is that we've also done a global analysis. Where are our last grasslands? That's what we wanted to know. And when you're talking about our world's grasslands, Nebraska is the fourth most intact, the Nebraska Sandhills, fourth most intact grassland remaining in the world. So if I was going to start, everybody keeps asking me, what are these metrics of success? We'd start with talking about the integrity of a system. How intact is it? The Nebraska Sandhills is number 4. In terms of true grasslands, I want you to hear these names. Serengeti volcanic grasslands. You're talking about some of the most iconic grasslands in the world, right? The Serengeti grasslands. You're talking about Mongolian Manchurian grasslands. Then we get into the Flint Hills, tall grass prairie, northern short grasslands, western short grasslands. These are our last remaining true prairies on the planet. Like, that's how rare they are. It's so rare to have even over 75% of them remaining. And across a ton of these areas, the conversation we keep coming up to over and over again is woody encroachment. So your true grasslands, they're rare. And we have one of the last remaining ones in our backyards. So I've been, again, fortunate enough to drive through and see enough of them. It's a rare vista, a rare culture when you're talking about rangelands and grasslands. So I appreciate what's here, and I appreciate what's at risk. So that's that image. I kind of want to ingrain that in our head, because I'm immediately, of course, going to talk about the threat. So we're increasingly recognizing woody encroachment as a national issue and a national priority. So this is actually a paper that just got accepted that was led out of a science team at University of Montana. So what they looked at was, for every place in the Western US, is an area increasing over time or decreasing or staying the same? So everywhere that's blue here is increasing. Well, cheatgrass is a huge problem in the Intermountain West. So that's an annual exotic grass. So you see all that increasing blue there, right? Here's where you have perennial grasses and forbs. Look at all the red in the eastern portion of the Great Plains. That's decreasing perennials. Where you have decreasing perennials, you have a huge amount of blue of trees. So all this kind of tells us, how are these most important functional groups? These are the most important measures that we could do in rangelands. Trees are increasing in rangelands more than anything else. And I bet you all of us are talking about bare ground more than we think about trees. We know to manage against bare ground like it's the plague, right? So this idea of trees are increasing more than anything else, and they're decreasing the least. This is a huge issue that's playing out now in these last couple decades. So this is a national discussion. It's just a different species playing out in a different area. Of course, when we think of our part of the world, and when scientists internationally talk about native species encroaching into rangeland, one of the biggest ones that always comes up is eastern red cedar. So it's a notorious native invader, and this discussion is why. All right, so we've kind of framed the issue and what's at risk. Well, the consequences of this are well known, and the challenges we have in front of us. One of the big ones being talked about is that globally, grassland biodiversity is declining. We have a greater loss of our grassland birds than any other group of birds. And when we look at these maps, where you see black on these maps, that's where we've lost the greatest amount of total abundance and total biodiversity of our endemic species. So we have this huge issue and huge crisis that's kind of confronting us. And in the Great Plains, we've also had a pretty nice go of it where we haven't had a truly problematic and impactful invasive species like something like cheatgrass or some of those. At the same time, we've not had major endangered species problems. So we've had a lot of regulatory certainty, and that's really helped our producers and production systems. Well, this is this warning signal that everybody keeps talking about of nothing's crashing faster and nothing's crashing more. And we know the threat woody encroachment has to grassland birds. So more and more, we're trying to give people advanced screening technologies to where when this happens, it doesn't change our entire way of life. So we try and prevent major problems so that, right, we're not stuck at home having a webinar instead of shaking hands, meeting in person. I think everybody caught the tone there. So screening for problems, we want to screen for things, we want to catch them as early as possible, and we want to prevent them from causing big impacts. That's one of the most important things we could do on this, rather than wait until we have a serious problem, diagnose the problem, and then figure out how to treat it. It's really hard to do that at really large scales. Diagnosis and treatment works awesome if we have a very localized problems, often like how we try and treat managing a blowout, for example. So this is a new age, and we've got increasingly technology that is meant to help us identify these issues before they become a major threat. All right, so let's get into I guess a little bit of the dirty of it then. So the spoiler alert is right on top. A group of scientists developed the ability to track rangeland productivity. And so that's something that you'll have more and more as we go forward into this in terms of your planning operations. But notice that where we have more public land, it tends to be less productive. So our average net primary productivity of rangelands in Nevada is the lowest. Our average productivity is highest in the Great Plains of Kansas and Nebraska. And that's associated with where we have more and more private land. So this is our most productive then biome and most productive regions for livestock operations with private landowners is the Great Plains. So I just want you to watch what's happening in the Great Plains, this 4th to 5th of the United States. Here we have the boundary of the Rocky Mountains. Up here, if you're able to follow my arrow, this is the Black Hills. And here's this boundary of our biome that we can track. So look at that red dot right there, right? Well, in this audience, everybody knows what that is. That's Halsey National Forest. So everywhere that looks red looks more like Halsey, and everywhere that's blue looks more like grassland. So think of this. This has taken 20 years of what I'm going to show you. This is 2000. Watch our biome since 2000. So that's 2018. So look how far that's moved and how much of, quote, the blue we've lost across these productive areas of Kansas, Nebraska, and what's starting to emerge in areas of South Dakota. You can see all this haze starting to emerge in the Sandhills. We're talking about a huge change. We've never seen these types of collapses, and no generation has had this kind of challenge. We're not managing just our backyard anymore, or our back 40. We're trying to think of how do we conserve what's going to remain of a biome. So that's the true scale of the threat. Our biomes are collapsing. These have been stable since the last ice age. So what are the implications and why is this happening? Well, everywhere that's red, we tend to focus on restoration. Everywhere that's blue, we tend to do improvements. So we plant fences, plant water, plant trees in the blue, and we cut down trees in the red. Well, that works really well unless this boundary's moving. If this biome's moving, future generations have to solve the problems of what's created in the past. So we want to try and remove this paradigm that's been really encouraged in range science and range management. We don't want to do improvements that cause us to do restorations in the future. We want to have a more sustainable approach and conserve that resource base. Well, what's happened is that we spent $25 million a year on average last decade. I mean, now we're talking almost 15 years ago in NRCS programs with brush management. So we're talking about a ton of money spent in the red because that's where we had the problem. Well, in the last farm bill, that was $177 million in the Great Plains. And we focus on the red because that's where we have a problem. We try and restore it. but look at how much area there is that's required to be restored. And there's seed sources all around, so it starts rapidly coming back. We're chasing the problem. We're not really solving the issue. And that's one of the biggest things that we're looking at here of a challenge and how to change it. And frankly, scientists have been studying this for over 80 years in rangelands. We know this, the causes and consequences of this, about as well as we know anything in rangelands. So how to avoid, these challenges and get in front of it becomes one of our big questions. So here's some of the consequences or challenges, and I feel like a lot of people know this, but when we're talking about Nebraska, I keep hearing we're one of the last strongholds for the greater prairie chicken. Well, we know those transitions are associated with a removal of available habitat for the greater prairie chicken. This is actually data from Kansas, whereas the walls closed in, whereas woody plants were moving in on these sites, it basically removed the available habitat. So this is a warning signal. There weren't any leks once you hit this level of a transition. Studies done consistently show how sensitive prairie chickens are. You're talking about 2 to 5% cover of cedar at large scales being a major issue. So you're talking about few trees, you're starting to get declining prairie chicken populations as that encroachment happens at large scales. It's true for a suite of grassland birds, and this really shouldn't be any surprise. Grassland birds require grassland habitat. Trees fragment grassland habitat. And as that encroachment happens, they're highly sensitive to it. New research out of Larkin Powell's lab even showed they avoided wooded areas more than they avoided wind turbines. So none of that's a surprise for those of us who have studied it a long time, but I just want to make it so clear in terms of once they start encroaching, grassland wildlife are really sensitive to woody plants. And that's because woody plants weren't here to that extent. It's fragmenting their usable space. So this is a big deal to grassland conservation. So avoiding that becomes key. At the same time, we have an 80% stocking rate decline that happens over time. So the birds are more sensitive than cows, but the cows come later. And that's because nothing really grows underneath these cedar trees. So you get this crash over time of potential livestock production potential. And this is a trend we've seen in long-term data in Texas, in Oklahoma, all the way up here in Nebraska. It's the same trend. So we get this crash over time. So this year-to-year variation caused by precipitation doesn't really matter if you don't have the forage resource base. So we're talking about one of the few issues where agricultural production and wildlife conservation are exactly on the same page. We're losing our native habitats and that perennial resource base that's able to drive some of those livelihoods. So I like to view it this way. When do those two groups react? Well, if we're a livestock producer, here's our percent earnings potential. So over time, we get this decline. And this was an example that we used for eastern Nebraska. Well, when do we act? Well, we react after we have this 80% crash. So we wait until we hit the bottom of the curve. And what happens is we even get accustomed to seeing trees thinking it's no big deal. So my kid's born, learns to drive, goes off to the University of Nebraska, for example, and you even, right? That's how long you've had cedar coming into your area. Well, then your kid goes off to college, and the next 16 to 20 years, you go through a midlife crisis because you lost 80% of earnings potential. The joke that's nobody laughs at in Texas is that they've sold the ranch 2 to 3 times to pay for cedar management. It just is a huge problem as this cycle keeps happening. So livestock producers usually react here. Well, let's think of grassland bird abundance. They're highly sensitive, but sooner. Well, we usually react at the bottom of the curve here. So there's 2 things here is that, one, conservation groups are giving us a warning. If they're seeing problems with birds, livestock is coming. So the clock is ticking. And in 2014, Nebraska Conservation Roundtable declared eastern red cedar is one of the biggest threats to conservation in the state. So the clock's ticking, and it's ticking fast. At the same time, I really want to get across this cautionary tip. Avoid this trap. As I show you examples as we go further, this is an example of discounting the threat. We're basically becoming desensitized to encroachment. And then when it's down here, we react to try and push it back up where we want it. And imagine if corn did that. I mean, if the corn industry said, we're not going to put our innovations into prevention. We're going to wait till we get compromised yield of corn, and then we're going to respond. And our goal is to see an increase in wildlife or an increase in livestock because our livestock and wildlife were compromised. Imagine if that's what we said with corn. They would be laughed out of the room, right? So I think it's really important to recognize we have a really odd kind of logic base, because this assumes we can control this problem and keep the system here. This is a challenge to take this mentality. I view it as a mental trap. There are 0 examples of this working on large scales, not a single one. And again, we've been studying this for decades in rangeland science. So this is a big deal of just thinking through, how can we move from here to the top of the curve? How can we prevent these kind of consequences with things like cedar encroachment? Because waiting to respond, not only do we have consequences to our resources, Dylan Fogarty did a study in the Les Canyons of Nebraska. So you have a restoration treatment that comes through this whole site. So all of the trees were consumed, all of the grasses were consumed. There was actually, this was a prescribed fire that went through here. It removed the trees, burned up the grass. Well, the question became, how fast does it take before cedar comes back? So in the cedar dominated area, Dylan was seeing cedar seedlings within 2 years. Whereas the area right next to it, when we track those over time, we're seeing cedar seedlings that aren't coming in there until year 15. So we have to manage after fire, just to keep this in grass dominance and prevent cedar from coming in so quick, we actually have to manage it now all the time. Waiting to act results in rapid reinvasion that's faster than the initial invasion. So that initial invasion's slow. If you wait till it hits this problematic state transition and becomes cedar dominated woodland, it comes back really quickly. Well, that of course increases risk to resources, it increases cost to management, and of course we're losing money tied to forage and perennial resources faster. So this is a really important result that Dylan Fogarty found, and it really starts to explain why groups over time have a harder and harder challenge after that initial invasion. So this is one of the key things that in areas of the Sandhills and those more intact grasslands, if we can avoid the transition in the first place, you can have a longer return on your investment. So let's step back. I'm going to show you some areas that are having success. And part of the message here is how hard it is to have success, because, right, it's easy to have success if you're out here in the blue. But once the biome hits you, once this broader source hits you, our life changes in terms of the challenges ahead of us, right? You are in a completely different system. So this is a big change. So here's the Flint Hills of Kansas. So remember when I walked through this, the Flint Hills of Kansas, they're the only large ecoregion left in this image. Everything else was kind of taken over. I kind of view it like termites in a Looney Tunes cartoon. They just went through all the houses and the Flint Hills was left. So let's look at the Flint Hills and look at what that looks like today. So here's this view of 2000. You can see a lot of these riparian areas in this image. Again, everywhere that's red is more dominated by trees, and everywhere that's blue in this image is dominated more by grasses. And in this, we're talking about a system that burns, right, 2 million acres annually. The last remaining tallgrass prairie ecoregion at this scale, and you know, very notorious for their fire management. Of course, cedar was rare historically because of human use of fire. So just look at this when I jump forward. That's 2000, there's 2009. Well, going back and forth, notice that cedar and other woody plants spread from where woody plants were in the first place. So we see very tight, spatially organized spread of woody plants. And you can also see that this success story so far is not looking as good as when I thought it would, based on 2+ million acres burning a year. We see a lot of areas compromised by woody plants and a lot of fragmentation in here. so there's not that view of like the Sandhills proper in the Flint Hills. And that makes sense. They're surrounded by woody plants now on all sides. And it's kind of veining through these riparian areas. And you can see, though, it's pretty stable in this last decade. And a lot of that's due to that fire management. And that's what, as scientists, we know fire does. It helps keep the woody plants at bay. So that's what it looks like. And they burn 2 million acres a year. So that's the caution, right? Like, this is what it looks like with 2 million acres burned every year. So if I step back, here's a bigger view of Kansas. Here's that Flint Hills view. There's everywhere that burns all the time, those darker pixels. So we now have data on fire occurrence data that Kansas Department of Health and Energy did. They're able to really connect these for us. And KDHE, you can see where it's deep blue, it burns all the time. And that's what makes this biome signal flinch. So it took that level. So that's the first example of what success looks like so far in our Great Plains biome. Now, of course, there's a bunch of challenges and trade-offs of having fire at that level and at that scale. And so there's a lot of conversations tied to the management of the tallgrass prairie ecoregion. But just to showcase to you all, like, it's the only tallgrass prairie ecoregion that's made this woody signal flinch. That's how hard that is. Well, let's go to the Gypsum Hills of Kansas. So this area is right in front of this kind of transitioning biome area. Again, more semi-arid site now. This is a 1 million acre view. So this is what it looked like in 2000. So here's a ton of cedar trees in 2000, really dense pockets of it. Here's the border of Oklahoma. So you can see 2006, notice where it's spreading from. It's spreading from where there were seed sources to begin with. So 2006, we see that pulse jumping. And once you get a lot more cedar like this, you start seeing a lot more rapid spread. So there's 2011. And look how it's starting to pop up in the western zone of this 1 million acre view and starting to create these patches. So you just get that deepening and intensifying woody plant pressure at large scales. And this is 1 million acres. There's 2015. There's 2016. So that was a wildfire, a 400,000 acre wildfire that just pushed cedar back into the recesses where fire didn't get in too much. And here was the boundary of that wildfire moving through. So that's what it takes to restore a significant area so far at large scales. In this system, it took a wildfire. Well, there's 2017, 2018. Well, you can imagine what landowners are thinking in this area. And I mean, I kid you not, one quote was from a rancher there that they were, look, wildfires are a huge problem, but in terms of my land, it was like doing cartwheels because I'd lost so much of my forage base. And they'd seen enough fire and knew what the productivity was going to do afterwards. So we haven't seen a restoration treatment like this anywhere else in the Great Plains. We're talking about a significant area where it moved back cedar, a significant portion of the county. And this group is looking to scale that up. Like, how do we prevent it from coming back so we can keep this landscape looking like this? This is what that wildfire looked like earlier this year or the end of 2019. So you can see this move of that signal where grass dominance is winning over some of the woodies. And here's a group of ranchers that are actually looking at figuring out how to keep it that way and not having it come back again. That coalition of ranchers and that culture is what we see as the basis for long-term sustainability of our last prairies. These last grasslands, that's how we know we'll all get it done, right? So yeah, in this case, when you have this much encroachment, they're waiting for almost like the line is, right, the act of God in order to get their rangeland back, because it would have cost so much to do it without a wildfire setting the stage. So that's the conversation there, and that's how challenging this gets. Well, then there's the story of the Les Canyons of Nebraska. So here we are, south central Nebraska, just south of the Sandhills. And we've partnered with producers there since I got here in 2013. I think we started in 2014, and really focused on understanding how woody encroachment is occurring in Nebraska. It's one of the most dense areas of cedar encroachment and the challenges that producers face in it. So same story, there's 2000. Everywhere in red, more dominated by cedar. Everywhere in blue, more dominated by grass. And you can see the war zone between cedar and grass with this image. This is a 330,000 acre region. There's 2005, there's the 2010. Just like everywhere else, the cedars are winning. And then all of a sudden you see 2015, 2016, 2017, and 2018. When we showed this to other regions, including like people in the Gypsum Hills, their quote was, finally, somebody's winning the war on eastern red cedar. Through management, not through wildfire and other things, but actually doing it through management. Here's all their management units, almost 100,000 acres of prescribed fires supported with mechanical removal. But what you're talking about here is they managed at the boundary. They didn't manage in the areas where it comes back so quickly. They're trying to manage at the boundary. Well, the results of this is that they halted the movement of this in this last decade. So ranchers over here can thank ranchers here for their work on eastern red cedar. And oftentimes they're working with them on these properties to help each other manage it. So I hope what I've done is paint a picture of how challenging it is for these groups. Once you have a significant problem at these scales, scientists often say that these are irreversible. It's so hard to get it back when you're talking about regional loss of rangelands to woody plants. It's usually viewed as irreversible. You're now just always going to have woody plants. So what we're trying to do is show, can it be something better than irreversible? Can we protect rangeland areas? And can we halt these transitions? And can we even gain back land lost? Those are some of the things that people are looking for. Well, the less canyons, like, it's not just halting transitions, which is one of the most important outcomes for us as science, is actually identifying the loss of where we were losing rangelands, and we can stabilize them. That's an incredible result. But the impact to producers is that they have 2,900 pounds per acre more forage when we did field studies on their areas. So that's, of course, direct money in their pocket as a result of these management approaches. 87% of the beetle, which is an endangered American bearing beetle in this landscape, occurs where they're doing management or in the blue, right, where there's more intact grassland areas. Based on long-term data from Game and Parks, only 4% or so live in and reside in this high-density eastern red cedar woodland. So imagine if we put all our investments there. It's more expensive to do it, lesser scale of impact, and this transition keeps going. If any local success of the beetle is overshadowed by regional decline that follows. So this we see as a great future for how to conserve our more grassland reliant species or species that require certain habitats. In addition, grassland has much lower wildfire danger than a volatile tree of eastern red cedar. So we're reducing wildfire danger within this system. And in addition, we're preventing lost revenue for public education, because a bunch of revenue for the public school system in Nebraska comes from grazing lease land from our Board of Education Lands and Funds. And just like everyone else, those grazing approaches are vulnerable because of eastern red cedar spreading through them. So we're talking about outcomes that go beyond just the rancher. We're talking about that what a rancher does on their property benefits endangered species and other wildlife, prevents natural disasters from being as impactful. We're talking about social programs. These are the future of outcomes that we haven't told in rangelands. Ranchers manage our rangeland systems. Our rangelands go so far beyond just benefiting agricultural production through cattle. We benefit the wildlife by keeping these systems intact. Our disturbances function the way we want them so that they're not causing natural disasters. And we actually have social programs tied to rangelands being rangelands. The protection of these systems are important. That's a story that as scientists, we're looking to tell more and more. And to me, that's the untold story of the ranching community is how much this goes back to keeping rangeland range. So what's the lesson learned? You know, one of the biggest lessons learned, notice I only had those few examples. So far, that's what success looks like. And the only groups who aren't impressed with those examples are the ranchers that live there. They're hungry for much better system that's easier to manage and easier to conserve and is more rewarding for their bottom line. But so far, because we waited to act, only fire in all of those examples has prevented or halted or moved back that signal I showed you. Only fire. That's the reality. As a scientist that studied it, we spent so much money on this with mechanical removal on woody plants tied to cedar, but it's so expensive we can only treat it at local scales. So this is the reality. If we wait to act, so far, only fire has done it. Now, I believe that more than fire can do it. So I want to get that point across right away. But in terms of going from hope to realistic observations, we've only observed fire working at large scales. We've hoped in the range discipline that other techniques would work, and they haven't. So how can we develop more proactive approaches where we can do more than just have fire? That's what people should get out of it. So think of it like this infographic down here. Rather than waiting till we're in the red, where we're calling out ambulances that are so expensive because our rangelands are in intensive care, we're going to do preventative medicine and preventative management, protect these rangeland areas, and grow them over time and push back these threats. We've done the exact opposite. In fact, when it comes to the challenges of woody plants, we put woody plants in the system, and now they're spreading even though they didn't in the past. So we actually have to cure our old remedy. That's that challenge of the improve then restore paradigm of rangelands. So I want us to think about this message because that's the message of the Sandhills. There's the Les Canyons, there's Halsey. You can see this haze of the early warning signal and just watch this play out over time. And we're highlighting this boundary to show you the general boundary at which woody encroachment is causing more woody dominated systems. So 2002 to 2007 to 2012 to 2017. And I've driven all through every road now that I can without landowners taking me places. And where you see the haze, you see these patches of substantial encroachment starting to happen. So here's where you have serious encroachment. This is the boundary of our biome now. It's moved so far west that we're talking about when you're going through this area in Loup County, you can actually feel the difference as you hit this boundary where there's a lot of trees and then all of a sudden you're hitting much more intact prairie. So what does that mean? Well, remember, we went from a system that had very few trees with very few seed sources to now you're going to have seed sources everywhere around your rangeland. It means your management goes up. It means reinvasion is faster. Over time, this speeds up. It doesn't just stay this initial rate. So we want to prevent it as much as we can in these areas. And we haven't focused on the blue because nobody told us to often. We thought we could just control it because mechanical removal and chemical treatments killed trees. The issue with them is they're so expensive. How do we treat a biome? How do we treat the state of Nebraska? So it's the same discussion that precision ag started having. How do we do things more precisely to keep what we want so we don't have to manage everywhere? So think of it this way. We put all our eggs into the reactive basket. So we have a whole bunch of increasing species, and this is invasive species 101. As you have increasing invasive species, the cost of your impacts go up and the cost of controls go up. So if you wait to react, we have poor success with invasive species. So we try and be more proactive, right? We have check stops for zebra mussels in some states. Musk thistle in Nebraska, it's like, oh, we're going to be highly proactive and do early detection and rapid response. But it's not just this trend over time or with certain levels. If you're in a place surrounded by the threat and you're the intact grassland area versus if this has very little of a threat, where do you think management's going to be more effective? If we turn this threat that's dominated by cedar into a grassland, is that going to be as effective as if we do it here? No way, right? It's surrounded by the threat, so it just comes pouring right back in. Whereas if we manage this more proactively, we have an intact system to build off of. We're anchoring our treatments, we're anchoring our investments. And that's how we can have more success. We did the exact opposite for the last 40 years with how we've implemented brush management. So the more we get ahead of it, the more we can actually start pushing back against it. And this is invasive species management 101. We just never applied it for encroaching woody species. So that's this view. How can we do this? And this great picture that Chris Helzer has. How do we protect these kind of really big intact rangeland systems? You know, again, fourth most intact grassland in the world. How do you protect it? And to me, this is the opportunity. We often say that we've studied this so much. We were trying to find pathways for people to have practical solutions. And that was no easy task, but it just finally hit us if we were looking at this all wrong. We've only looked at managing it when we see mature trees and when we have a transition to a completely different non-grassland system, a cedar-dominated woodland. We have to understand the process of how this encroachment happens. So what you have is you have an intact grassland, and eventually some nearby seed source sends a cone into your rangeland. And that seed source allows recruitment to happen. So you get a seedling established. Well, that seedling causes a mature tree, which then has more seed developed, and you're in this cycle of spread. And that spread over time causes our grasslands to be converted to an unproductive state. Understand how to manage. So when I think of what grasslands then truly are, grasslands were treeless. And they were treeless at large scales, and they were treeless at large scales for thousands of years. And they did not, across a ton of the geography of grasslands, have seed that compromised our grassland. They were seedless, they were treeless, and they were that way at large scales. So the reason that we didn't have spread across a bunch of our grasslands wasn't necessarily because they were more arid, it's because they didn't have a seed source there. And that seed source wasn't there because it was more arid. So our intact grasslands, that's the good old days. We don't even have to manage woody encroachment. Life's so good. Those days are going away for a lot of people in the central and northern Great Plains. So what happens next? Well, then you get this dispersal phase. Well, that's where you might have this view, but if there's seed sources there, you're compromised by seed. What I want you to think about that as a high maintenance zone. So there's research that's been done so far that suggests most of the effective recruitment is within a football field of the seed source. So where's your seed source? Is it your windbreak? Well, if you're going to have that windbreak, there's a high maintenance zone around it that you ought to view it as. You want to prevent a mature seed-bearing tree from establishing if you want to keep rangeland, because that tree then sends tens of thousands, hundreds of thousands of berries out into your rangeland and creates new big trees. So now 100 meter became 200, became 500. So in order to keep management small and localized, keep that dispersal phase under control. If you're in the recruitment phase, you're doing loppers, and this is the earliest I ever saw anybody manage cedar encroachment. So people started managing seedlings before this problem occurred, and it became so expensive. But I definitely want you all to know we can do even more. We can go further back in this invasion process. There are ways to keep a lot of area intact, because I don't know anybody who wants to manage seedling recruitment across a vast majority of the Sandhills. We want to prevent seedlings from establishing across a bunch of the Sandhills. To do that, think of the seed. The seed is coming from somewhere. So understand that process. This is the key to more successful approaches than the few that I've got so far in the Great Plains of where fire is the only solution, because we waited till we got down here. And this is recruitment phases like early detection, rapid response. You never let a seed-bearing tree get to here, because once it hits encroachment in the Great Plains, we've studied this a lot. I view it as a management trap. It's like mission impossible. Good luck keeping it in this encroachment phase. It's so easy to keep speeding up and go to a major transition. And that's where you're either waiting for an opportunistic opportunity like the Gypsum Hills, you wave the white flag and you accept a new life without grassland, or you try and restore it. And that restoration, you saw the challenges of places like the Les Canyons in terms of doing it, and they didn't do it the typical way. So this is new scientific guidelines as a result of being able to work with producers, work at real scales instead of really small scientific experiments. And these are what we've learned of how can we better manage this spatial spread of invasion over time. It's coming from seed sources and spreading from seed sources. So rather than be traditional and reactive, what could we do to be proactive? I think there's a bunch of things I could learn from ranching groups and different managers on how different management can manage recruitment, prevent dispersal, and keep grassland intact. But I definitely want to give you the warning. I only have a few examples at large scales if this happens. So that's the warning. So let me do a couple of examples for you, because I think this should be the basis of a ton of conversation that starts to happen over time. How can we actually get this system where we want? Well, if you want your system intact, a treeless grassland not compromised by seed, well, first off, I want to dispel the myth of traditional restoration. The way we viewed it was that if you put mechanical removal into here, it would take you all the way back and restore your grassland. That is a myth. It doesn't happen. Thinking of this through the invasion process, this is not correct pathway. I want everyone to understand that this is why our brush management didn't perform as well as we wanted it to. It doesn't do this. And that's kind of how we painted the picture. And to be clear, that this is all science. This is how we've kind of viewed it historically and talking about this in the science. So we're pointing the fingers right at us. These guidelines should change. So don't buy into this myth. What really happens with mechanical removal is if you do a single restoration, it takes you back to the dispersal phase. Well, why is that? Well, because you have a legacy of a seed bank, right? You have these mature trees that have been there a long time with a bunch of seed. So what you have, no matter what, is a dispersal phase. You have recruitment that's going to happen. So when we do things like cost share, a single restoration, and don't think of how to follow it up, what we get is this. So if I was to say the most likely outcome of where we spent all of our money, I would say the likely outcome of brush management is more brush. And that's because we didn't actually have a real plan. Imagine if we had no grazing plan. It was just, I'm putting out this many cows this year. Like, we have to actually start creating brush management plans if we're down here. And that's the benefit of being in the good old days. The good old days, we didn't have to do that. So yeah, this is our reality of a single restoration. This is what the system does. And this has been replicated all over the Great Plains, with this being the reality of woody plant management and doing just a one-off. So of course the question is, how do you get to here? If you're in this phase and we're trying to push the system all the way back, you have to do seed bank depletion. And oddly, this might be the single most easy species to do it. Based on evidence that exists, the seed bank is short-lived in grasslands. So if you're able to get this started and promote a grassland, you have a short-lived seed bank, whereas lots of species have very long-lived seed bank. So you could deplete the seed bank here and create a treeless system that has no incoming seed. That means no nearby seed sources within that kind of football field zone. And then where you did these restorations, you depleted the seed bank. Otherwise, it just goes back. So this is the realistic aspect of rehabilitating our grasslands. We let our grasslands go to a completely different ecosystem. It's not going to be a silver bullet. We actually have to do rehab and in order to get them back. So if we want the good old days again, this is the pathway. I think there's a lot of ways to make this happen. The key target is just don't let a seed-bearing tree come back where you did a restoration. That seed-bearing tree produces a bunch of babies. So there's your warning. Prevent that right there, right? Don't let it come back this direction. Seed bank depletion, even seedlings aren't creating seeds. So you're just trying to prevent this over time and trying to push that system more intact, because this one's easier to manage and it's a lot cheaper to manage. But as soon as it slips, now we've lost a portion of that initial investment. And by the way, reinvasion happens faster than initial invasion. So this is that critical management target. I'm just going to give you this one example But what I see playing out is an actual discussion on how to do this. If you're an intact grassland with no seed, we can walk through a pathway of how to keep it there so that you're avoiding dispersal phases from ever happening. But also realize that's the risk of a windbreak. A windbreak creates dispersal. So, well, what do you have? Well, you have a high maintenance boundary around it. Just know that you are managing the risk of the windbreak, because we have that windbreak for particular benefit. You just don't want that windbreak to encroach onto your other assets. That's why I love the line of some people in the Sandhills told me that, you know, this outdoor barn, it's really saved our bacon, but we don't want it to eat our whole lunch. That's kind of how it feels over time. So I'm just painting this picture of this is what prevention could do for us if we started to get over or get past the unrealistic expectations and how this process actually works. This is the reality of woody encroachment in rangelands. This happens. So prevent this because it's really hard to get it back. So thinking of this, I want you to think of this as kind of tabular in a thought process. Usually people are picturing outside your window, but I want you to think of this spatially. Think of if we have to do this everywhere. If 100% of our funds are on emergency care, it is so expensive. And look how much of the system needs it. And if we prioritize 0% of our funds here, but even if we have 100% of our funds in, we're going to lop off seedlings, that's a huge amount of land area. We want to have some area that is not compromised at all. That's good old days of rangelands. But I want you to see what happens with traditional guidance, where we have to manage everywhere. To treat 5,000 acres, and these are real producer costs, and thank you, Shelley, for talking about some of your examples earlier. 5,000 acres at $150 per acre, which is what I've heard producers tell me is one of the examples in the Sandhills, that's $750,000. So if this starts coming back over time, right, that single restoration treatment, well, what are we going to do after this to keep it where we want it, to keep it over here? Well, people in Kansas and everywhere else are telling me it gets up to $1,000 per acre. So to treat 5,000 acres is all of a sudden $5 million. And these are actual examples that I've talked to with groups. So that's a huge amount of cost for a system that has a lower profit margin than other agricultural land uses. Well, of course, we don't have 5,000 acres to treat. To treat 40% of the Sandhills, or 500,000 acres with traditional guidance, would cost us $75 million at $150 per acre. That's half of what was spent in the Great Plains in the last Farm Bill on brush management. This is actually our traditional guidance. So it costs so much to do it, and yet we're just not able to manage enough land area with it by waiting. So this traditional guidance and calling out the ambulance, we know that hasn't worked. The best thing we can tell groups that are in the blue is to avoid that approach. Let's adapt our programs and move it forward. Oh, by the way, why? Because also, while control cost skyrockets, the double whammy hits. Your income from forage production crashes. So both of those happen at the same time. That's the challenge of this issue. Well, I want you to think about another example here. What if we thought of this like precision agriculture? So we don't have to apply management everywhere, but we apply it strategically. So here's the seed sources on the outside of this kind of silly cartoon. I swear I'll have a better illustration at some point. But here's the seed sources on the outside. This is a 500,000 acre area. If our seed sources were on the outside, the seed has to disperse to come in because it's not all coming in from inside. So it has to come from the outside. Well, in that case, we would manage the boundary. So we could use these different tools instead of these really expensive ones, use these cheaper tools, manage the boundary. We could manage, in this example, 4,500 acres because that's that 100-meter effective recruitment boundary. Now, that's just based on the literature, right? So we have field studies we're doing in the Sandhills this summer to try and confirm that, but I'm just painting the picture here as the illustration. If we did this on 4,500 acres, we could bank the rest of the land area. So that would cost $22,500 to conserve a 500,000 acre area. Precision ag at its finest, right? Precision brush management. manage the boundary, defend the core, and then grow the core strategically. Protect the assets that we want at large scales so that we don't have to manage everywhere. This has never been implemented at large scales until recently, thinking through this and starting to walk through this and develop this with different landowner groups. We do see this in practice. Nothing quite yet this big, but there are examples moving forward. We're in the 6 digits, 100,000 plus acres, where let's defend our areas and protect them and avoid, even if we want seed sources, right, or windbreaks in certain areas, that's great. We just don't want them compromising one of the last remaining intact grasslands in the world, the Sandhills and other important grasslands. All right, so here's that study I showed earlier. This is just so people have it and can see it. We're gonna conduct a more rigorous study as we go forward. How about some light there? I realized I'm talking in the dark, which probably was great and also a little creepy. So this is where some of this information's coming from and other studies, but again, they haven't been implemented here, conducted here. That's something we're gonna grow off of. But it's the logic of this. You can see in all the examples I've given you, we now know that encroachment isn't random. It's not everywhere. It's not, we kind of manage it like we want to manage agricultural conversion if you're in wildlife conservation. Like, where's agriculture going to happen next? Where's it going to convert a grassland? And that's the risk. Well, that can happen anywhere. This doesn't do that. We should be managing woody encroachment thinking spatially, because it happens spatially. And we've got the tools in our toolbox and creativity to do more than what we've done in the past. So that's the picture I'm painting. There's still a lot of uncertainties, but the logic is there, and we know it's better than our traditional approach. Finally, I think this is critical. One really important point to make is that shortly after settlement, prior to the dawn of modern ecology as a profession, scientists said that woody encroachment couldn't happen below a certain precipitation threshold. And we can now test that. So those hypotheses came from 1890s to 1920s science. And they said it couldn't happen out here. So we've studied that. Here's that line where if you're east of this line and have more rain, that's where disturbance was supposed to be needed to prevent woody encroachment. If you're west of that line, climate makes woody encroachment not possible. That's the old hypothesis. Well, again, we'll go to Dylan Fogarty here as part of his dissertation work. So we'd used a number of field sites all across the Sandhills, and everywhere you see an X in it, we saw woody encroachment happening. Not that it could happen, it's literally happening now. It's just at lower densities. So the rate of encroachment is slower here, but not possible. It is absolutely possible. And we can drive all over the entirety of the Sandhills pointing out, yes, it can happen here. It is happening here. And just because it's not happening to your windbreak now doesn't mean it won't. It will, it's just when. So I think that's the key areas. It's going to be more the exception than the rule, that woody encroachment won't happen. In fact, there's only a couple sites here that didn't have woody encroachment. And guess what? They didn't have a seed source near them. And that's why. So it wasn't about aridity. It was actually about there wasn't a seed source in the Sandhills in the 1890s to 1920s as you went more arid. It became increasingly rare. So our grasslands were grasslands because they weren't compromised by seed everywhere. Well, now there's seed everywhere. So how do we start to recognize that is the source of woody encroachment? And just to be ready, because while we see it here, it's really low density, and we can really start to implement those proactive tools. We just want to remove this denialism that was spawned from a century ago that it's impossible. If we get on it now, it's easy. If we wait, it's incredibly hard, and we have few examples of success. So I think we could scale this up and actually really get ahead of this now that we know this stuff and have much better success than we've had in the past. So what I'll leave it with is this again, because this is where I keep coming back to that keeps me up at night is this opportunity that lies before us. And for me, I think there's an incredible opportunity to unite, all the groups who really care about grasslands and want to see those grasslands remain. but the future of those grasslands depend on what we decide to do next. And there's no certain future. We see the biomes collapsing. We know the consequences. Are we going to conserve our last big grasslands and start to push back? I want to tell that success story. It'd be one of my favorite things to do as part of my career. But the rewards tied to just working with you all and us trying to think through how to make this easier, how to make it more profitable, how to get the conservation values we want, and all the things that come from conserving rangeland that we've taken for granted since settlement. Wow, we have an opportunity together to do something better. So what's that future? I mean, that's what I'm hoping as people watch this recording and so forth, we start thinking about. And that's really where proposing these partnerships, we're going to see more and more of it. We want to keep our rangeland systems healthy and intact. We want to sustain those rancher livelihoods, prevent wildfire danger from coming to the Great Plains, protect human health, protect our water resources, and all the other things that come with big intact ecosystems. So with that, I'm happy to turn it back over to Shelley, and really just look forward to engaging with you all a lot more. We expect to be out, and we really want to learn with you all, because that's what all this came from. This was a producer partnership science. It's like a private land science. We're just doing science in the room and learning by these big picture actions of these rancher groups. So thanks again, really appreciate it. And Shelley, it's all yours.
Thanks so much for that presentation. It's always so wonderful and helpful to see all that stuff, and scary at the same time too. Very eye-opening. Thank you for listening to ranchers. Thank you for developing information that helps us so much over the years. It helps guide our decision-making process with the Sandhills Task Force on how we're going to spend funds and help ranchers out. So I can't thank you enough for that. I do want to give you a quick opportunity to introduce Dylan and what he's doing to support you, if you'd like to do that too.
Yeah, that'd be great. Thanks. Dylan's been really serving as a key point of coordination with private lands, and it's not just here; it's across multiple states. So you absolutely, I'm getting to be up here and tell a story, but what you have are people like Dylan, who's doing a ton of work, not only on the field, but all this is the result of him doing this great work working with landowners. So Dylan, we were going to put you on the spot and just let you share a little bit of what you've been doing and what you look forward to doing a little bit more as we get out in 2020.
Yeah, we've been coordinating with rancher groups from Kansas and in Nebraska, working to speed up that communication between the science and management on the ground. That's been really rewarding, and it's been really helpful from our end, hearing from them, and they've benefited from getting the science as soon as we're learning and making advances. So yeah, it's been great, and we're really looking forward to working in the Sandhills with folks.
Wonderful. Well, thank you very much. I'm glad that you're here, and I know that this partnership will do nothing but improve over time as we get going. So, and so thanks to both of you. If there are any questions, people can unmute their screen or unmute themselves and ask a question. I'm going to see if I can pop up the contact us information again so that we can have that on there too. So I'm going to share my screen. There, so you guys can have that too. But I think we can wrap up from there unless you guys have any last quotes or last things to say.
Yeah, if there's any questions, happy to take some. Otherwise, one of the things that everyone can expect is there's just so much momentum from multiple agency groups. You know, I kind of mentioned that at the beginning. You know, whether it's the NRCS, Nebraska Game and Parks, and there's a laundry list now. I mean, you all know that better than me, but we're seeing a ramping up of that discussion and partnerships. So I'm really excited to see how Sandhills Task Force and different landowner groups, in combination with this really ramping up of agencies for support. In addition to I've never seen so much commentary and discussion around this with, you know, groups like cattlemen associations and others. So all that should lead to where we're more active and out there and engaged with you all. So I think that's one of the big key things that maybe we haven't had in areas like the Sandhills, is just, you know, on this particular issue, really good engagement. That's what we've been working with Shelley and Dylan's been doing, so that we can learn from you all, but more rapidly get that science in your hands, and you all can make better decisions as you see fit. So yeah, if there's no other questions, we'll break off, but I just, again, appreciate the opportunity for dinner and a movie, I guess.
Yeah, well, thank you for giving us your time, and it's working. We've been working together for 6 years. We started, both you and I, Dirac, started about 6 years ago. We've probably actively been working on it for maybe 2, and I think we're just getting started. So I'm excited to see where we're gonna go. Thanks to those that logged on. We'll make this available online so you can share the link with your friends once we get that posted. It'll be right on our website at sandhillstaskforce.org. Thank you all so much.